we had this problem right here. A recipe for 1 loaf of bread calls for 2 cups of flour, 12 tablespoons of water, and 1 teaspoon of salt. Now, I'm going to tell you the biggest error that I saw with this problem. The biggest error I saw with this problem is that people put 8 right there. People put 8 right there. Why do you think people put 8? They were looking at this and they were just going multiply by 2, multiply by 2, multiply by 2. We can't do that. We can't judge that. Now, this one is helpful. This one's times 2. That one's times 2 for that one. So let's see. Raising your hand, because we know this one's times 2. We see 1 to 2 is times 2. What answer would go there? Raise your hand and tell me. Yes? 24. Exactly. You guys, our easiest row of all of them. On your fingers, what answer goes here? The easiest row on your fingers, what goes here? 2. So make sure that we are using our fingers to communicate when we're doing that. You guys, easiest, what goes here? Show me your fingers. What goes there? Look at that. Perfect. Easiest row. That's okay. I mean, we only have so much time, but that's fine. Plus, question number 7 is the hardest, and that's the one we get to last. So, okay. We've got this one again. This next one, everybody should get. Who can raise their hand and tell me what we get? What do we get? 8. Just the times 2. So far, we filled out all of these. The biggest issue I had was people put 8. People put 96. And some people didn't even get the, put 8. I don't even understand how they did that. But I want to know. That's not the actual thing. It's not actually times 2 times 2. We can't just make up our own pattern. The only piece of information I have is that right there. That's the only piece of information I have. So I'm going to look at that. Sean, what did you get? How did you multiply it? By 3. Is that what we should do? What do you think? Yes, exactly. What we do is we multiply it by 3. The reason we multiply it by 3, the only piece of information I have is this one. I'm going to look. From 2 to 6 on your fingers. What's 2 or 2 times what is 6? On your fingers, 2 times what is 6? Perfect. Times 3. What we do to one side? We can do better than that. What we do to one side?
Do to the other.
Nice. So we just do the same thing. You guys, fingers up, the easiest one right here. What goes right there? Exactly the easiest one, as we know. 3 goes there. What about here? Also 3. You guys, did you notice that those 2 columns are just the exact same on the test? Like they should have been exactly the same. And then this last one, who can raise their hand and tell me? 36. Can you just assume the pattern? You can't just assume the pattern. I know these ones followed times 2, times 2. But if I did this one, does this one follow times 2? No. So you have to make sure that when you're watching, you pay attention to these. Like I said, make sure that you take notes that help you. Make sure you take notes that help you. Okay. Now, we actually did a practice problem with this next one. We actually did a practice problem. Okay, so quadrilateral EFGH is a scaled copy of quadrilateral ABCD. So it already tells us they're scaled. Label each statement as true or false. Remember when I was in the back and I tried to show you guys with rectangles and all of that stuff, right? We're going to look at it with rectangles again. So I'm going to draw a rectangle A, B, C, D, and I'm going to draw a rectangle E, F, G, H. So there we go. I drew my 2 rectangles. So here's what we're going to talk about. This is what's really, really important. These shapes look weird, don't they? In fact, the only thing we can classify them as is polygon / quadrilateral. We can't classify them as anything else. They're not trapezoids. They're not anything. Can I find the area of those shapes? No, I can't even try to cut it into composite shapes and find the area. I physically can't find the area of those shapes. Yeah, look, there's there's one that's asking an area question, but how am I supposed to solve that? I can't find the area. Does it tell me what the angles are for any of them? Like, does it tell me, oh, this angle is 30 degrees or anything? No. Oh my gosh, there's an angle question, so we've got to think about that. Let's look at it. We're just gonna do it, and we're gonna make up questions of our own, because this always works. You can be fair. So I'm gonna label this side 2, and I'm gonna label that side 3. I'm gonna label that side 2 and that side 3. I'm gonna label this side down here 4. So far, does that resemble what we've been given here? That resembles a lot what we've been given, right? Those are pretty close. I would like to know what my answer is going to be for right here and how we know. For right here and how we know.
6 because 3 times 2 equals 6.
So Matthew says 6 because 3 times 2 equals 6. What do we think? Yes or no?
No.
We're getting no, we're getting yes, we're getting a mix. 7 says yes. How did he get, where did that 2 come from? Think of the scale factor on the side.
Because we multiply 3
Oh.
by 2 as well.
Yeah, because what we did here, we had to do times 2, right? And what we do to one side, oh, we can do better than that. What we do to one side, okay, Anna, no. Talk to her. Oh, go after her, yeah. You need to be taking notes if you want to do a retake. I'm going to talk to her. Okay. So, my apologies. So you guys, here's something that's helpful. Are you ready? Here's something that's helpful. I literally just want to write this. How long is segment EF? We just found it. How long is segment EF? Who can tell me? What does it say on here? Segment EF? You will be doing the whole test all over again if you didn't get a perfect score, but still. Ready? Yes. It's 6. That just says it right there. Oh, these marker colors are terrible. It is 6. Who can tell me the length of AB? Who can tell me the length of AB? I want some new hands going, but go ahead. Yeah?
3.
So would that statement be true? Yeah, I just labeled it, right? If I'm doing the length of CD, you guys, I didn't write it on there, but what is the length of CD? We can be super duper smart. I didn't write it on there, but what is the length of CD? On this one. I didn't write it, but remember this is a rectangle, so what length would that be? It would be 3. CD is 3. FG, again, I didn't write it, but what would this be if it's a rectangle? 4. Is that true? No, notice all I'm doing is I'm just writing, like as soon as I see segment CD, I go, what's the length of that, right? If I was looking at here, I would write 6, CD, I would write that 6. I just write it there. This fact, true. That fact, false. Now here's where it got tricky. You noticed that it was all times 2, right? Twice, twice, twice. So you would think that the angle is also going to be twice, right? Who can remind me what the angles are for rectangles? Yes. 90 degrees. You guys remember my joke? I always tell you this. If you're cold, go stand in the corner. It's always 90 degrees. Ha, ha. So, I've got a question. If I get my rectangle to be bigger, did my angle change? If I made my rectangle bigger, did my angle change? No, it didn't change, did it? No, because it's still a rectangle. So the angle did not change. This next one, it says the length of segment EH is 16 units. On the test, was that accurate? Yeah, on the test, it was accurate. Because here we've got 8, we did the times 2. So on the test, it was accurate. Here, I'm not going to change it. Then that last one, the area. Again, a lot of you, can I find the area of these ones right here? I cannot find it. So you're like, okay, miss, how am I gonna solve it? That's why I created my own fake ones right over here. That's why I created my own fake ones. Raising your hand. I want to see your hand. What's the area of this top one? What's the area of this top rectangle? Raising your hand. Only getting like one person participating. Only getting like 2 people participating. What's the area of this one?
Wait, I don't know.
It's 6. Don't overthink it. I know that you're like, oh my God. Who can tell me what the area of this one is? So just by thinking about that, is my area twice that amount? Is my area twice that amount? No, it's not, because 6 times 2 is 12. Here's a fact, you guys. I expanded one side times 2, and I expanded the other side times 2, 31. I expanded one side times 2 and the other side times 2. Notice that this went up times 4. What's 2 times 2? 4. That's how it worked. If I had a different one, because I'm just going to give us a different example just to show you a fun thing about area. I'm going to go up. I'm going to have my sides, my area here be, let's say, okay, let's say 3 and 5. And then this one, I'm going to have 9 and 15. My area here is 15. My area here is 135. Notice that from here to here, it's times 3, right? This is just an example. Notice that from here to here, it's times 3. What we do to one side? If I did 15 times 3 times 3, I would get 135. That's because I did times 3 on this side, times 3 on that side. That's just a fact. It's not something you need to know for the test, but it's just a fact, right? So the area does not double when my scale factor doubles, because area is length times width. So side times side, side times side. And what we do to one side, we do to the other. Okay. How do we feel about that one? Do we feel a little bit better about that one? Knowing that our angles stay the same, knowing our stuff. Awesome. Okay. There are a couple ways to do this problem, but I'm just going to give us the easiest way to do it. Okay. I want you guys to raise your hand as soon as you see an important piece of information. As soon as I say something that's important, I want you guys to raise your hand. Are you ready? Rectangle A measures 9 inches by 3 inches. Ooh, you guys are doing a lot better than my other class. Yeah. 9 inches by 3 inches. Awesome. Rectangle B is a scaled copy of rectangle A. Nice. It is important that it mentions that it's scaled. Could I solve this problem if it was not scaled? No, because then it could just be any numbers at all and that wouldn't matter. And we would get the gordita cat, the flaquita cat. Like it wouldn't work. We couldn't get it. Then it says select all the measurements that could be the dimensions. Are you ready? There's another way. We can write ratios a couple different ways because this is ratio tables. But I'm going to give us the easiest way we can do them. I'm literally going to write this as 9/3. I'm going to write it as 9/3. And don't worry, I'm going to explain it to us. And by the way, you might have done it a different way. You might have done it a different way, but this is a way that always works. How do you think I'm going to write A? Raise your hand and tell me, based on what I did for this top part, how do you think I'm going to write A? What do you think I'm going to write A like? Do we have any guesses? So look how I wrote this one. What might I do for this one? Do you have a guess? What do you think?
4.5 over 1.5.
Valentina says 4.5 over 1.5. What do we think? What do we think? Yeah. Notice that she kept the same unit order, Who can tell me how I would write B? How would I write B? I want to get some new hands. Come on. Yes. Yeah. 8/2. How would I write C? How would I write C?
10/4.
10/4. How would I write D? Come on, I need some new hands. I'm getting the same one person. Yes,
13.5 over
13.5 over 4.5. And the last one, how would I write this? 90 over 30. Here's what's cool, you guys. Like I said, remember how we talked about how we can make our unit rate or whatever on either side, right? I could have written this as 3 to 9. But if I wrote this as 3 to 9, does that match? No, I would have to flip it, right? So you would have to make sure that you keep it matching. Our notes, they're always important. In our notes, we want to make sure that you always know you keep the matching pieces together. You keep the matching pieces together. I am going to now bring up a calculator and we are going to see, I'm going to show us what we're doing to solve. Okay. So our first one here we know is 9 over 3. I want it to match 9 over 3 because you guys had a calculator on your test. So what you guys are going to do, you could do this. Ready? 9 divided by 3. What does that give me? 3. So I want my end answer to simplify to 3. Let's check our next one, right? I'm going to do 4.5 divided by 1.5. Is that the same as 1.5 divided by 4.5? It's not the same. I hit enter. What did I get? Did it match? Yes, A matches because I got 3. You guys, just being big brain, what is 8 over 2 simplified to? Who can tell me what 8 over 2 simplifies to? What is it? 4. Does that match? No, we know that one doesn't match. Just being big brain again, by the way. 10 over 4. Do we think that's going to simplify to 3? We know it's not. In fact, it simplifies to 2.5. So this is also not correct. Like I said, now the other ones are a little bit harder. Well, this one is. So I'm going to do 13.5. And I'm going to divide it by 4.5. And I get, what did I get? Does it match? Yeah. So that one matches. Hey, you guys, just being big brain, 90 and 30, is that going to work?
Yeah.
That one's going to work. What if I gave us 900 and 300? Does that match?
Yes.
What if I gave us 9,300?
No.
No, right? Look at that. You guys are so big brained. You guys are doing really well. Do we understand how we could write those as fractions and use our calculators in order to solve that? There are multiple ways that you can do it. There are multiple ways. But I always make sure to teach us ways that will always work, that might help you, that do things like that. So I'm going to stamp our notes at the end to make sure that you guys took notes for the retake. We're doing the retake on Thursday, Friday. Okay. Okay. I had several issues with this problem. This problem had several issues with it. Now, again, I want you to raise your hand as soon as you see an important piece of information. As soon as I say something important, I want your hands to go up. A scale drawing of a rectangular park is 5 inches wide. Nice. Technically, yes, we could underline scale drawing too. That does work. And 7 inches long. Ooh, we got that. The actual park is 280 yards long. Ooh, nice. You guys are doing great. And then it says, what is the area of the actual park in square yards? It's mentioning square yards, which means that I actually don't need to do any conversions. I don't need to do any conversions. Now, we had several problems. The first problem is, one of the main answers I got was 35. What's wrong with that answer? What's wrong with it? They did it in inches. This is my scale drawing of the park. Is it the actual park? No, it's not the actual park. So that's what's important. The next error I had was people not labeling ratio tables. They weren't doing it right. So I'm going to make myself a nice ratio table for this one. Normally I do 3, but because I already know that this one's going to be nice for us, I'm just going to make it 2. What might I want to label the top of my ratio table? What might I want to label them? Maybe think of words that it's mentioned. Ooh, so inches in square yards. Those are pretty good. I like that. That's not how we're gonna label it. Length and width. The reason we know is it says the words wide and it says the words long. It says the words long and it says the words wide. Now we fill this out. We fill out our initial ratio, right? I know it says 5 inches wide. So I'm gonna put 5 on my wide side and it says 7 inches long. I'm gonna put 7 there. If you're wondering why my L looks like that, that's because you will see that on tests in the future. You see, I probably write pounds like that too. I write LBS like that. You'll see that on tests. You'll see that on things because otherwise L's kind of look like ones. Okay. Now, I got that 280. Here was the second biggest mistake people made. I want you guys to point to the side of the room that I'm going to put the 280 in my ratio table. Point to the side of the room that I'm going to put that 280. I want you to take a guess. Oh. Yes. 280 goes on this side. Who can tell me why? Why does 280 go on that side? I don't know. Yes. Because it literally says the word long. We keep long with long, don't we? Okay. Now, do I know what my width is yet? Do I know? No, so I gotta figure it out. I gotta figure out how I go from 7 to 280. We can be smart. How do I go from 7 to 28? Show me on your fingers what I do from 7 to 28. 7 to 28. Show me your fingers. 7 to 28. 4. But then it's got a 0 at the end. Times 40. Like I said, nice and loud. What we do to one side? So I do times 40. The next biggest issue I had was people were trying to figure out how to go from 5 to 280. And they were writing 56 because 5 times 56 is 280. And then they were multiplying 40 and 56. That's not what we want, is it? What we do to one side, we do to the other. Should I be seeing 2 different numbers when I'm doing calculations on the sides? No. 5 times 40. 5 times 4 is 20. So I get the answer of 200. But am I done yet? No, I'm not done. It doesn't ask me what the actual width is. It asks me for the area. You guys, how do I find area? What's just the formula? Yeah? 200 times 280. Length times width, right? When I do 200 times 280, I get 56,000. I get 56,000. Do we understand? Does it make sense that a park is going to have really big area? Yeah. You guys have been to parks before. Do you think the park, even if you weren't paying attention and you thought it was in yards, does 35 make sense for the size of a park? No. Like, even if it was 35 feet, even if it was 35 yards area, that doesn't make sense. And then if we went up 35 miles, does that make sense for like a normal park? No. 35 does not make sense. 56,000 feet and yards, whichever one it could be, because that makes sense, doesn't it? Because it's yards, but like I said, if you're just thinking about it in general, it makes sense. Think about things that make sense. Especially, guys, if you're getting 35, we can't have 35 if the actual park is 280 long. Can our area be smaller than one of our sides?
Yeah.
Can our area be smaller than one of our sides?
Yeah.
No, our area can't be smaller than one of our sides. Okay. So those who put that 35, they found the area of the scale drawing of the park. Now, we scaled it up by 40. Now, this is just a fun fact. Again, I mentioned it with the rectangles. If I had 35, this side was times 40, this side was times 40. If I did the math, 35 times 40 times 40 gives me 56,000. It's just a fact because I multiplied that side by 40, that side by 40, and that's the original area. It's just a fact. You don't need to know this for the test. That's just a fun fact. Okay. This one, everybody should have gotten this one correct. Everybody should have gotten this one correct. Here's a polygon. Draw a scaled copy of the polygon using a scale factor of 1/2. Using our hands. Is 1/2 gonna expand or is it gonna reduce? So show me in your hands. Excellent, it's gonna reduce. This was also really helpful because can I fit a bigger one on here? I can't fit a bigger one on here, can I? Now, just because I can't fit a bigger one on here, doesn't mean that that's gonna be like you're always in, but we know 1/2 is reduced. I never got an allowance, but would you rather get one whole allowance or 1/2 allowance? Whole allowance, because half is less, right? All we have to do is count the sides. 6, 8, 4, 4, 2, 4. If it's half, what am I dividing by? 2. Remember we talked about scale factors? Times 1/2 is the same as divide by 2, right? We talked about that. Denominator means divide. So for example, if I had the fraction 2/3, what that means is I divide by 3 and I multiply by 2. That's all that means. So you guys, if I were to redraw this, I would get 3, I would get 4, I would get 2, I would get 2, I would get 1, and I would get 2. Just by looking at it, does that look the same as my original shape just scaled? That's a good indicator that that's the correct answer, that it looks the same when it's scaled. I had people turn them in where it did not look the same scaled. And that's when you know, that's when you look at it and you see, okay, maybe they did not scale it correctly. They did not do that. These ones should be pretty easy, right? Like so far, this problem has been, like this one should be the easiest problem. Okay. Now, we're getting into our 2 hardest problems. Okay. Everything we can solve, though, can be solved with a ratio table. This ratio table, I'm going to make like I actually want us to always make our ratio tables, but I've been helping us and just I've been helping us and only doing a 2 when I know we need a 2. But all your ratio tables should normally be a 3. Do we always use the one in the middle? No. But do we sometimes? Yeah, and if we don't have that, that's going to be really inconvenient for us. It's going to be really inconvenient. We'll never need a 4 if we're just finding out one ratio. I do 2 ratio tables because there's part A and part B. Part A and part B, 48. What do you think I want to label? Because we always make sure, this is very important. Label our tables. Ha. Label our tables. What do you think I want to label this one? What do you think I want to put? What do you think I want to put? Yes. Centimeters and kilometers. Do we agree with her choice?
Yeah.
Yeah, because that's what it says. Isn't it going to be the same thing for this one? Same question, right? Who can raise their hand and tell me my original ratio? Who can raise their hand and tell me my original ratio? Yes.
4 centimeters and 5 kilometers.
4 centimeters and 5 kilometers. So I'm going to put my 4 in my centimeters, my 5 in my kilometers. Isn't it the same for the second one too? It's the same original. We know that because it literally says so in the question. Now, I'm going to have you tell me, what's the important thing that I need to know in question A? Raise your hand and tell me what's the important thing I need to know in question A. I'm getting like 3 people who are going to get so many minutes today. Yes.
The actual distance is 4 kilometers.
Excellent. The actual distance is 4 kilometers. I want you to point to the side of the room, everybody, that I'm going to put that 4. Point to the side of the room. Bitch, you guys are killing it. I'm going to put the 4 there. What about this next one? Because I'm just going to do them both at the same time just so that we can do it. It says what? What am I looking for in this one? Who can raise their hand and tell me what I'm looking for? Yes. 5 centimeters. Point to the side of the room that I'm going to put it. Point to the side of the room. Excellent. Now, here's why I have that middle one. First of all, just in case we need it. But second of all, can I go from 5 to 4 straight out with multiplication or division? Just no, I can't do that. Their greatest common factor is 1. Notice I put it in the side I have all the information for, right? Because would it help me if I put it on my other side yet? No, I can't do that. I need the side with the information. To get from 5 to 1, I divide by 5. To get from 1 to 4, I multiply by 4. What I do to one side? Do to the other. Divide by 5 times 4. You guys had calculators, which means that you likely can get it as decimals, but if not, you can just write it as a fraction. Who can tell me what I got in this section right here? What did I get? Yes. 0.8. By the way, 0.8 is the same as 4 fifths, because that's the same as 4 divided by 5. Same thing. Who can tell me what I got right there? I want somebody. Zoe. 3.2. 3.2 is the same as 16 fifths, because all I did was I multiplied 4 fifths times 4, right? Either one of them is correct, but if you have your calculator, do that. So the actual distance is 3.2. I've got a question, and we're going to think if this makes sense. Which one in my scale number is bigger? I'm not talking about if centimeters or kilometers is bigger, but which one on my scale numbers is bigger? Is it the 4 centimeters or the 5 kilometers? Which number is the bigger number? 5 kilometers. So isn't my kilometer side always going to be bigger than my centimeter side? So my kilometer side is always going to be bigger. Does that match with this row 2? Does that match with this row 3?
Yeah.
So we know that that makes sense. That answer logically makes sense. If I was getting a different answer, if I was getting like 4.7 here, do you think that would make sense? We need to think what's going to be bigger or smaller. We're doing the same thing here, but in this case, we had our centimeters. In this case, we had our centimeters. So here, I divide by 4, and this time I multiply by 5. What I do to one side? I want us to be better than that. Divide by 4 times 5. A big mistake, because I saw people go divide by 4 on this side and divide by 5 on that side. We can't do that. Just like I keep saying, what we do to one side, we do to the other. 5 divided by 4. Who can tell me what 5 divided by 4 is? Yes.
1.25.
1.25. Excellent. 1.25 is the same as 5 fourths, because isn't that 5 divided by 4? What do I get as my final answer? 6.25. 6.25 is the same as 25 fourths, because it's just times 5. Those are the same thing. Whichever one you put would be fine. Do we see how we got these answers? Do we see why it's important to label our ratio tables so we know what side to put things? Remember when I was talking about the pizza and the guests and all of that? If I had put them on the wrong side, would I have gotten the right answer? And again, doesn't this follow the rule of the kilometer number being bigger than the centimeter number? Doesn't that follow that rule? That's how we know we're getting it right. If it isn't following that rule, then we're not likely getting it right. Okay. Last problem. Last problem. And a lot of you guys struggled with this one, but it's the same thing, ratio table wise. Same thing. Okay. So there are 2 different maps of Ohio. Because of that, I'm going to create 2 ratio tables. I'm going to create 2 ratio tables. I'm going to put them down here just so that I know it's very inconvenient. And these ones I'm just going to make a double just because I know that it's going to work out for me. But on your paper, I want you to do always triple just in case. What do I want to label these at the top? What do I want to label these at the top? What do I want to label these? Centimeters, kilometers, centimeters, kilometers. I'm going to do this first one. It's going to match here. This one is just going to match there. Because don't I have 2 different scales provided? I have 2 different scales. What do I want to put for this first one right here? What do I want to put for this first one? Yes. 1 centimeter, 10 kilometers, right? What do I want to put for the second one right here? 1 centimeter, 50 kilometers. Now this is tricky. Which map do you think is actually bigger? The 1 to 10 or the 1 to 50? What do you think is bigger, 1 to 10 or 1 to 50? What do we think? Who can raise their hand and take a guess? What do you think?
1 to 50.
You think 1 to 50? Do we have any other guesses or do we agree? Do you agree? Or do you have a different guess? You think it's 1 to 10? What do you think? 1 to 50? Let's think about it. Are you ready? I'm gonna give us an example. So here is a length that I'm gonna do. This is gonna be a 1 to 10. I've got the same length here, but this one's a 1 to 50. Do we understand how I've got the same length for both of them, but this one represents 10 and that one represents 50? Obviously, that's not really 1 centimeter, but if I wanted to draw 1 centimeter, you guys wouldn't even be able to see it. Let's say your parents are gonna give you $100. I know, right? I know. Let's say your parents are gonna give you $100. On your fingers, how many of those would I need to equal 100? On your fingers, how many would I need? I would need 10. On your fingers, how many of these would I need to equal 100? 2. So which one's actually taking up more room? That one, right? Because doesn't that take more? If they were giving it to you in dollar bills, or if they were giving it to you in bills, would you get more $10 bills or more $50 bills? More $10 bills. So that one's actually bigger, surprisingly. But that's not the point. The point is the next part. I want us to raise our hand when we hear an important piece of information. I've already read the scale. So we did this. The scale of the first map is 1 centimeter to 10 centimeters. Ready? The distance from Cleveland to Cincinnati is 40 centimeters. Excellent. Point to the side of the room that it's going to go on. Point to the side of the room. Perfect. I'm going to put it in my original. 40. Easy peasy, you guys. 1 to 40 is times 40. Times 40. This bottom one, just because I'm going to say, we get 400. Awesome. I had a couple problems. People multiplied 50 and 40. Those are 2 different numbers, aren't they? Like this is kilometers, that's centimeters. We can't do that. And some people left it at 400 or they did something like that. This is the actual distance, right? Isn't 400 kilometers the actual distance? And that makes sense because doesn't it make sense that the real distance would be about 400 kilometers between these 2 big cities? That 400. What do you think I'm going to do with it now for this second part? What do you think I'm going to do with it? Ooh, that's really good. Really close. You're so close there. 400 is the kilometers. Don't I want to put it in my other ratio table? Because aren't they the same thing? Point to the side of the room. I'm going to put that 400. Exactly. Because now it's a kilometer. 50 to 400. On your fingers, how do I go from 50 to 400? Show me on your fingers, how do I go from 50 to 400? Times something. From 50 to 400. I got some people. Not 10, not 10, we got that. It's 8. So I do the same here, times 8. 1 times 8 is 8. The distance on the second map is 8 inches. The distance on the second map is 8 inches. Would my distance on the second map be this gigantic number of 2,000 centimeters on the second map? Does that make sense even if I had 40 centimeters on one map and 2,000 on the other? No, that doesn't make sense, right? Why would I have a map, by the way? What kind of use would a map be if I had a map that had 2,000 centimeters to represent something? Is that a helpful map?
No.
That's not a helpful map. But 8 centimeters represents it. That's pretty solid. It's a pretty small map. We got that because we need to carry around our maps. Do you see? All you need to do is keep matching the information you have with the side of the ratio table that you get. Label your tables. I know, it's really funny. Label your tables. Okay, you guys. Excellent work today. Excellent.